Um, Apologies for starting up a little late. Today's been an interesting day. But let's go ahead and dive on in. So, last week on our beginner coder stream, talked about a bunch of the basics. So we talked about let's fire up a new file. Talked about variables. So we talked about const and let, with the difference being that const, once declared, can't change, and let can change. And to start off with const, we talked about our basic data types, our string, our numbers, our booleans, we talked about arrays, which are lists of other data types, including other arrays. And we talked about objects, which can have various things inside of them. And we talked about functions, which are chunks of code that you can rerun. And we mentioned that there's a couple different types of functions. So we got arrow function and regular function. And then we did a couple different examples. So we modeled out what might be like an enemy class, start of an enemy class in a video game. We used arrays to loop around and grab some code, or grab some scores, and then we print out the average. We wrote a function to hunt for the prime number and used our loops, which I forgot to mention. We did loops. So we learned the while loop. So while something is true, or while the condition over here is true, it's going to keep going. We learned about for loops, which have some iterator, and it keeps going. And we learned about do while, which are like while, except they'll always do it at least once. And yeah. So yeah, if you weren't here last week and you're interested, the full stream for the first one is up on YouTube. So I'll kind of reiterate things as we go along with new stuff. But if you didn't catch the first one, be sure to check it out on YouTube, because we covered a whole lot of basics in that stream. Okay, so what I want to do today is I want to take the skills we learned last week, and we're going to start learning how to do some basics of game design. So using actual graphic coding. So I'm going to fire this guy up real quick just so we can see. So on the mainstream, we've been using Canvas to do some basic game design stuff. So I want to talk about the basics that go into something like this. Really simple example. So let's go ahead and alright, I'm just gonna blank this out. It doesn't really run. Okay, so let's start out with creating a root element in our HTML. So this is just going to give us something to hook the rest of the stuff we're going to create in our code. So in our first stream for the beginners, we pretty much just did everything in the console. So we pretty much did everything here, and we did use prompts to get some input. But This time we're actually going to do something in the page. So I'm going to just create a div here, and I'm going to go ahead and open this up in Chrome. So right click, open in Chrome. Alright. And that div didn't put anything here. But if I inspect element, I can see that it's right here. It just, there's nothing in it that causes anything to render to the screen. So let's close that guy out. So let's go over here. And first, so with normal web pages, we generally use HTML, which is what you see here. So like if I wanted, say a list of something, I would use a UL. If I wanted a paragraph of text, I'd use that. If I wanted, I'd use a paragraph tag. If I wanted a header, I'd use H1 or H2, 3, 4, 5, 6, etc. So that's what, and then we style those with CSS normally. Style, body, background, paragraph, like shade of blue. And these colors here are what's known as hexadecimal. That's an ugly shade. And oops. And there's a whole bunch of different rules. So you can see my text changed there. Whoops. And my background is already white. Black. Well, now I can't see my text. And you have a whole bunch of rules that you can apply different values to and change it up and position them and stuff. So that's what we use to style normal web pages. But if we want to do game design, what we most often use is what's called or anything that's not just game design, but anything that really like is doing like image transforms. So like if you wanted to like create a tool that like does photo manipulation, that's not really a game, but it would also use the canvas probably. So pretty much anything like that, use the canvas for. So let's go ahead. We'll create a canvas in our code here. So if I want to create an element, doesn't matter which element it is. In JavaScript, I can do document.createElement, and then it's just the tag name here. And the tag name is the word that's inside the angle brackets. So body or script or title or style or whatever. So create canvas. That's going to create a canvas element. It's not going to put it anywhere yet. But then what I'm going to do is I'm going to do, we'll get a hold of the root element, which, oops, I deleted the root element. Get a hold of the root element here, to get a hold of any existing element, you can do document.querySelector. If you want one, you do query selector. If you want multiple, you do query selector all. Query selector will give you just one. Query selector all will give you what's called a node list, which is kind of like an array, and normally you just transform it into an array. But we'll just do the one for now. And then the selector, it takes CSS style selectors, which are how we filter those. So when I had the CSS here a second ago, these were selectors. These are element selectors, which are just the tag name. There's also ID selectors, which put a hashtag or pound sign before the name, and that will find anything that has an ID equal to this name. So that would target root. You can also have classes, and you can target those with with a dot and then the name of the class. The difference between these two is for an ID, you should only ever have one ID on the page, or one element with that ID on the page. It should be unique to that element. And class, you can have any number of elements for. So yeah, so So over here, I'm going to do pound or hashtag because I want the ID root. And that's going to give me a reference to the root over here. And I can actually console log these guys out and see the elements. So we can see I have a canvas and the root element. What's nifty with Chrome is if you get a hold of an element on the page and you mouse over it, see on the left, it's actually highlighting the element. The element has no height, but if it did, like, let me put something in there real quick. See, it actually highlights that element, so you can check to make sure you got a hold of the right element. Canvas doesn't highlight anything because it's not attached anywhere yet. Let me go clean back up this HTML real quick. So now what I'm going to do is I'm going to attach it. So I'm going to do root element dot add child, or sorry, append child, and that's going to append the child to the canvas. And append meaning it would put it at the end. So if the root element already had a bunch of things in it, it would put it as the last one. And there are, so there's not a prepend. There's yeah. You can also do insert befores to if you wanted to stick it in like above something else. But almost always, I think I've used insert before like once. I mean, there's use cases for it, but I don't come across them very often in what I do. So now we can see our canvas was appended, but our canvas is white, so it blends in with the white background. We don't actually see it. So let's go ahead. That white's a little bit blinding. So let's go ahead. Let's make our body black, the whole background, except for the canvas. Well, it did the canvas too because the canvas is actually transparent because we've never drawn to it yet. So we'll make the canvas white there. And then let's go ahead and we'll make our canvas bigger. So I can change the width and height of things in CSS, but Canvas is a little special in that it has really two different widths. It has its natural width, and then it has the style width. The difference between the two is kind of like an image. So with an image, if you make an image and you make it, that was weird. If you have an image and come on, Photoshop. Let's make an image. I'm gonna make like an image of like 100 by 100. So if I have an image, I draw something, and then I make it bigger, it gets all blurry and pixelated. So that's the same with Canvas. A Canvas's natural image is like this one, 100 by 100. And then the style would either shrink or grow it, but it may get pixelated. So instead what we want to do is basically the equivalent of changing the canvas size. Name coincidence? I think not. So we're going to change the size of the canvas and then draw onto this guy. And that way we'll have a bigger image without it getting all pixelated. So that means we want to make sure we change the canvas's width and height in code. So we change the natural width and height. You can also, if you're adding the canvas directly as an element, you can also set it here. And this is also the width and height, like this. You can set it as attributes. But I almost always generate my canvas completely in code just because it tends to be easier. So we'll go with 800 by 600. And I'm just picking those semi-arbitrarily. It is a 4/3 ratio. That'll fit on our screen. Or we can do, I guess 4/3 is actually kind of old-fashioned nowadays, isn't it? Normally you would do 16:9 or 16:10. So we'll go with a 16:10 resolution. So 800 by 500. That's 16:10 because if you do 1610, you get, what do we get? 16 divided by 10, you get 1.6, and if I didn't screw up my math, that should be 1.6. So that's how I can tell that it's that resolution. It's also just half of 16 and half of 10, so that's how I was able to do it in my head real quick. So yeah, so we set that. So now we'll flip over here. So we can see it got bigger. Now we'll go ahead. Now we want it, it's kind of awkward being over there, so we're going to get it in the middle of the screen. So what I'm going to do is first on the canvas, I'm going to set margin 0 auto. So elements have, oh right, we need a display block. But elements have basically four dimensions for them. They have their own width and height. Then they have padding, border, and margin. And you can see Chrome illustrating them over here. And we don't have any padding and margin border in this guy. We might have padding on body. Nope. And these three are used to kind of help nudge it into position. So padding is on the inside of the border, and then border is outside. Or border is the border, and the margin's outside. So I set margin, and I set it to 0 auto, which basically makes it auto left and auto right evenly, so that centers it. Unfortunately, auto doesn't work like that for centering the height. Centering in the height is actually a huge pain in the butt. Can we do a padding? Oh, we have a margin on that. Okay. So I'm going to get rid of the margin on the body, just so it doesn't mess up our calculations. So that'll make the canvas go right to the top. And now I'm going to set, for the HTML body, I'm going to set height 100%. And before I do that, I'll show you why. So see, the body element is actually only going down as far as the stuff that's inside of it, so the canvas. But if I want to be able to center vertically, I need it to go all the way to the bottom. And the HTML element, which wraps up the body element, is doing the same. So I'm going to force both of these guys to be 100%. Get rid of that extra space. So now it goes all the way to the bottom. Now what I'm going to do is I'm going to... actually, you know what? The easiest way to do this, we'll just cheat a little. We'll do position absolute, position relative on the body, and then position absolute here. So when I do position absolute, I can set a top, left, right, and bottom value to be exactly where I want within its closest relative parent, its closest relatively positioned or other absolutely positioned parent element. So these are gonna be relative to this guy, so 50%, 50%, and that's going to actually stick the top left corner 50% away from that side and 50% away from the top. And when we talk about positioning elements on a computer screen, 0, 0 is up in the corner of our screen, and then the numbers get bigger as we go down. So it's kind of like if you took your standard Cartesian coordinates, you kind of rotate it about the x-axis. Grab my tablet real quick. So, like you may have learned, about your Cartesian coordinates, your normal graphing stuff in math class, and you have, so things get bigger as you go to the right, and smaller as you go to the left, and then get bigger as you go up, and bigger as you go down. So you'd have like a line going that way, and that would be getting bigger as you go. So computers are basically the opposite. Well, they're the opposite for the y, but they're the same direction for the x. So we still get bigger this way, and we still get bigger this way. And you can technically go negative. That puts you off screen. But negatives would take you this way and this way. So 100 by 100 would be measured 100 this way and 100 this way. So, and when we're working in a web browser, our 0, 0 is actually the corner of here. Or in our canvas, the corner of here. depending what we're talking about. Okay, so now that I'm here, I want to now get it pushed back. And the tricky, I can't just be like, I can't just sit here, play with these numbers and kind of find what looks good. Excuse me. Because what looks good on my screen at this size won't necessarily look good on your screen, or it won't look good when I change the shape here. You can see it moves over. So if I found like the perfect value that made it look right here, it wouldn't look right here. So what I'm going to do instead, I'm going to stick with 50-50, and then I'm going to do transform, which is like it's a graphical transform. Then I'm going to use translate. So you have a handful of different things in transform. The main ones are rotate, scale, and translate. So translate is just a fancy word for move. And the difference between top and left and translate. Top and left, these values are relative to its parent. So it's half the width and height of body. Transform, all the percent values are based on itself. So these are half of the canvas. So to get it centered, if I moved it halfway here and got its top left, to get it back positioned, I would move it backwards half of its width and backwards half of its height. And that'll get us perfectly centered. So there we go. And that'll stay put no matter how I kind of abuse my screen and change its size and stuff. And eventually we will get to a point where I'm too small, but it still stays centered. Alright, so cool. So now we got our game centered here. And that's enough. That'll be all the CSS and JavaScript we're doing. We'll talk about CSS and JavaScript a little bit more later. But for now, I want to focus on our game stuff. Okay. So created a canvas, got a hold of our root element, change your canvas size, and actually let's just chuck this up here, and put and appended our canvas to our element. Doesn't really matter what order we do any of these in. Now what we want to do is we want to get a hold of the context for the canvas. Canvas.getContext. So getContext gives us basically the drawing context, and there's currently 3 of them, really 2 of them. One's an experimental version. 2D or WebGL, which would be 3D. We're going to stick with 2D for today. So, what this context does is this gives us access to all the things we need to draw to our canvas. So, but yeah, actually, real quick, a quick note on WebGL. So WebGL, well, and the 2D really, are both very kind of low-level access to the web stuff, to the drawing stuff. So WebGL to the 3D stuff. What I mean by low level is it can kind of be tricky. Let's find a quick example. Example of WebGL code. Let's see what it sounds like. What is this? It doesn't really look 2D. Or 3D rather. But yeah, see, so they have, yeah. You have a lot of low-level calls even in this one, like drawing buffer height and a whole bunch of things. It's not exactly the kind of example I was hoping for, though. But anyways, if you're interested in doing 3D stuff, I would probably recommend finding a library that kind of simplifies it. So you may be familiar with Unity or the Unreal Development Kit, UDK. Those are kind of the 2 big 3D game engines that are popular right now. Those 2 basically take the kind of siblings of WebGL, OpenGL or DirectX, or what is it? Do they use Vulkan now? Vulkan or other buzzwords. Is Metal the one? That's the Mac one now. Metal. I assume they implement Metal. Maybe they don't. Yeah. But anyways, all of those are kind of similar to WebGL, and they're very low level. And then what things like Unity and UDK do, along with putting it together and giving you boilerplate, it also kind of simplifies things. So if you're interested in 3D, it's going to be a little easier to start out than diving straight into something like WebGL. GL means it's using hardware acceleration, so it's more performant. Can be 3D or 2D. Regular canvas uses self-running. Yeah, that is true. Yeah. So, yeah, WebGL doesn't actually use... Or WebGL is for drawing graphics. It doesn't actually super duper dictate whether it's 2D or 3D. And so it will be faster. But, like I just said, it's also much more complicated. So unless you need the performance, what we're going to do, the regular 2D, which does use software rendering, it's much easier to think about. And even if you wanted to do 2D WebGL, I would still go hunt down a library. Actually, I've not looked at any lately. WebGL library. I'm sure there's some out there. Oh yeah, 3GS is a good one, actually. This one I have actually used before for, not for games, but for some more simple things. Yeah, and so this is one of those that I was talking about. They kind of simplified down a lot of the WebGL stuff. Let's see. Let's see. I've not used any of these other guys. Have heard of this guy. This is Portive Processing. But yeah, so if you are interested in WebGL, you could also check out some of these guys. But okay, back to the easier version. Okay, so we're going to go with the 2D context. Okay, so the 2D context, basically, we're going to be, we have, in a nutshell, we can essentially draw, and actually I'm going to abbreviate this to CTX. Normally I avoid abbreviations in my variable names because abbreviations can make your code less readable, because like unless you know what that abbreviation means and it's like a super duper universal abbreviation, someone else reading your code may not remember what your abbreviation is, or you may not even remember 6 months later. But CTX is like such a super commonly used abbreviation that I do use CTX in my code. Like if you look at MDN, all of their examples are not that. Going to be using CTX for all their stuff. So it's one of the few abbreviations I do actually use because it's so simple or so universal to Canvas. So basically with CTX, if you want to draw anything on the screen, you have two types of what we'll call them, drawing actions maybe that you can do. You can either fill or you can stroke. So fill is going to fill in whatever path or shape you make. Stroke is going to put an outline around it. And you can actually do both. So like if I wanted to do, say, and you set a fill style and a stroke style to control the color. So fill style. And these can take some fancier options, but the basic way is just you provide hexadecimal color values, like I was doing for the background and color and stuff earlier. And what these color values are, if you're not familiar with them, so unless you have a fancy monitor that's now mixing in like yellow and black channels and stuff, most monitors have 3 color channels, RGB, red, green, blue. And so hexadecimal colors basically are defining in an 8-bit way as how much of each color to mix in. So you have your first two is your red. So it's hexadecimal, so you're with 2 letters, or 2 digits, you can go between 0 and FF, which in decimal would be between 0 and 255. which is 8 bits. 256 is 2 to the 8th power. And then your second pair is for green, and your third pair is for blue. And when you mix colors, unlike mixing paint, when you mix color in, so here I'm going to play with those numbers directly. 0 color means black, so because we're mixing light, so 0 light is off, so it's black. And then crank it all the way up in one channel, and you get just a lot of that color. Crank it all the way up in all 3, you get white, because when the colors mix, they give you white. And then somewhere in between, you get your mixes of colors. So, green and blue is cyan. Red and blue is fuchsia. Red and green is yellow. And then if you wanted, like, say, orange, that's somewhere with, like, half green and red. And, you know, you could kind of mix them around in here. But yeah, so that's the colors we're dealing with. So, and then in HTML specifically, well, like CSS and that stuff, when we're dealing with colors, is it magenta? Actually, I think you're right. Let's double check. Yeah, I said fuchsia, but I think it is magenta. Red and what is that? Blue. What color is it? But yeah, and FYI, light mixing is additive, and like paint mixing, pigment mixing is subtractive mixing. Yes, it is magenta. Thank you. You're right. Yeah, I said fuchsia, but it is magenta. Okay. But yeah, so in CSS Colors, when we have each pair has the same letter for both digits, like this one, we can actually drop one of the extra digits. So this is the same as AABBCC. Just as kind of a shortcut. And that shortcut comes from back in the day when everyone was still on dial-up, and those 3 letters were expensive to send. Nowadays, not so much, but I use it just because I like taking less. Yeah, and some IDs like IntelliJ here will show you the color that it's making if it can recognize that you're making a color, which is always nice. And you can also always just go in Photoshop and find the color you want and then just copy the value down here. Yeah. So things like Photoshop have a different several color spaces we can play with. So they're just different ways of representing colors. So we have HSB here, which is hue, saturation, brightness. There's also HSL, which is very similar, but the L stands for luminance. So that's basically hue. It's a degree around like a color wheel, and then S is how much of that color you have, and then B is how bright that color is. So I think probably a lot of artist types probably use this one more often. And then RGB is how we pick hex colors. It's a little weird to pick your colors indirectly because it doesn't really correlate to how we think of colors. And then there's lab, which I forget. It's weird. I don't know that I've ever picked a color in lab. You have basically L, which is lab luminance, or L luminance in lab color space. No. Lightness. And then A and B are color dimensions because that's super descriptive. Don't know why you would use that. And then CMYK is for print. So when we print stuff, we print with cyan, magenta, yellow, and then black, basically. But yeah, so if you were doing print work, you might be concerned about these colors more. But yeah, they're all just different ways of representing color, though. And there's more than just these 4 out there, too. There's several. But anyways, TLDR, though. If you want a color, you don't have to work out the math. Just grab a color picker. And even paint. Does paint show hex? I don't remember if paint shows hex or not. Paint. It doesn't show RGB. You can actually do math here to figure this out. If you basically, because you can convert to hex, you can do 127 divided by 16. So 7's our first digit, and then do 7 times 16 minus 127. And then 15 is our next, which in hex we go 0 through 9, and then we do A, B, C, D, E, F for the next. So 15 is F, so 7F would be this color, basically. Or you can also cheat, and if you go Programmer Calc, you can type in the number in decimal, and then click on hex, and it'll give you the value. So you can get it that way, although if you're resorting to using paint, just Google for color pickers, and there's a whole bunch of them online that will give you hex values. Anyways, okay. So for let's draw a rec. I'm going to do this bluish color for my fill style. I'm going to do stroke style, and we'll just outline him a very dark gray. And I can also do line width to control how thick the stroke is. And then I'm going to do, so for rectangles, we use the fill rect functions. And they take an XY, so where they start, and then a width and height. So I'm going to do 100, 100, 500, 500. And we'll just do the fill first and take a peek. There we go. And that's actually bigger than our screen. Let's shrink it down a bit, because our screen is only 200 or 500 high, and I started it down 100. So there we go. So it drew the thing, and remember we count. So it's 100 from this side and 100 from this side right here. And even if I was to, so I mentioned Canvas has 2 different sizes. It is its natural size, and then it's kind of HTML size. Even if I was to change the size with CSS, how it draws is still going to be relative to its original size. So even here, it'll still draw it as if it was regular size, and then it gets shrunk just like an image or blown up. But yeah. Okay. And then if I want to do a stroke on that same spot, I basically just call stroke rect with the same exact values, and then it'll do a stroke on top of it. So there we go. You can see it's 3 pixels wide because I set that as my line width, and it used that color. And you can actually, if you flip these around, and it actually draws it on top of one another. So if you flip those around, now the stroke was actually like centered, kind of like halfway on. So like if this is the stroke, it actually centered it on the edge of my rectangle. So it overlapped a little bit of my rectangle. So here I flipped them around and drew the fill on top of the stroke, and so I cut off that overlap part. Usually though, you would just, you'd always do fill first, because you generally want your stroke to be on top. And each draw action is literally just kind of painting the canvas. Look, I prefer using Color Picker in VS Code. If you don't have that, get a nice CSS extension. Oh, thanks for the tip. I haven't actually used VS Code's Color Picker. But yeah, another color picker I like is, if it still exists, let's see. Yeah, Cooler from, I assume that's how you say it. I've never actually heard anyone say it out loud. Cooler from Adobe actually lets you pick whole color schemes and stuff. It's really cool. It's geared more towards like web design, but it's really handy for picking colors too, and it gives you all the hex values. But yeah, there's a lot of cool values out there, or cool options out there. Okay, so we have our square here, and each operation is literally drawing on top. So like if I was to just kind of go here And I'm going to change the fill style and go with red. And I'm going to do, say, 200, 100, 300, 300. This is just going to draw on top of my other rectangle. So you can think of it exactly like if you were using paint on a canvas. You put down paint and it goes on top of whatever paint you just overlapped. So if we want to clear it off, we can use the clear rect function. And we just do 0, 0, and then we'll do canvas.width, canvas.height. So we'll start all the way in the corner, and we'll go for the whole width of the canvas on the whole height. And that basically just blanks it out. And we could also do, if we wanted to, we could also just do a fill rect of white instead of clear canvas. But clear canvas is better. That's what it's there for. So, same thing. But yeah, and then, so fill rect and stroke rect are for rectangles. If we want to do a circle, we have to use the arc function and the path. So everything else is pretty much, except text. Here, we'll do text real quick. That's the other easy one. Fill text, so very similar to a rectangle, except we give it text, so a string, and then we give it a position. And then the text will draw as much as it needs to get the text down for its current font size. The difference being that we can optionally set a max width if we want it to only go so far. So like, let's grab some lorem ipsum. Lorem ipsum. Lorem ipsum is some like dummy text that's used for a lot of design things. If you need something that looks like text, that's not actually lorem ipsum right there though. If you need some dummy text that doesn't really mean anything to like throw in your design, usually you'll grab some lorem ipsum or something. And it's basically, I think it's a rearrangement of like Dante's Inferno or something. I'm sure it explains it in here. But yeah, someone came up with it though, quite a while back. But yeah, so I'm just going to grab a chunk of that to have a big long set of text, and then I'm going to draw it on the screen without a max width. And you can see, so it's actually pretty tiny. It's not very big there. I can do CSS font, and I can specify font style. And this is the same styling as you would do for CSS, and there's also a bunch of some other options in there. So if I type font, you can see, so I can do like the font family without the font size separate. The font family is just the name for the font you're using, and you know, variant weight, so that's like bold and italic stuff, weights for bolding and variants for italics and stuff, etc. But yeah, but it's using the fill color, or I can actually do stroke and I can get an outline of the text, although that's a little small so it's hard to tell. If we go really big, you'll be able to see it's an outline. There we go. So you can see there it's an outline. And then if I wanted to limit how wide that is, I can set a max width on here, and it'll do that. it'll force it to be within that width, so it just literally took it like an accordion and went down to the size. Usually you'd want to avoid that in most cases because it can get really ugly, but it's there if you need it. Another way would, if you need to tell how big your text is, you can actually use the measure text function, and you put your text in here. We'll just console log what it gives us. And it'll tell you what the width would be if you drew it, and then also usually fonts don't sit right on 0, 0 in like a nice neat rectangle. They'll usually go above it and below it, So that's what the ascent and descent is. That's kind of how much it deviates from your nice clean X rectangle. And then it's also not perfectly on left and right, so it's actually -7 to the left of what would be 0, and then it goes for this for that much, and you basically add these two together. Well, I guess you add their absolute values together, and that's what gives you your width, really. Maybe that's actually weird. Yeah, never quite lines up right. Font is funny. But you can use this if you need to like plan out how to position it. Like if you wanted it centered on the screen or something, you can do that. And there is also you can do text align. So if I wanted it, say centered, for example. So like I want to draw it centered on the screen. I can do canvas.width divide by 2, and then canvas.height divide by 2. I'm going to shrink it down a bit, or else we won't be able to really tell that it's centered. And I'll go back to fill. So what it's doing here when it's center is it's putting the middle of the text at my position, which I've done half the width and half the height, so right smack in the middle of my canvas. Well, at least for the left and right. So text align applies to left and right. There's also text baseline, which applies to up and down. So if I wanted it centered up and down, I would use middle. So there we go. So that's perfectly centered now. And you can see all the different options. Text align. And by the way, I think I mentioned last stream, but MDN is by far my favorite resource for looking up anything JavaScript related. It's great. It's by Mozilla, who's the makers of Firefox. Definitely the best resource out there for JavaScript. And I usually just, if you don't put MDN, it's still usually within like the top 3. But if you want MDN, throw MDN on there and it comes up. So text align, our options are left, right, center. So those 3 are pretty obvious. Left will put the position at left, right at the right, center, center. Then you have start and end, which, do they have picture images of it? Yeah. So start and end are a little bit different. It's starting it at the start of... Do they have a picture in a different language? No. It's the start of where the text should be based on your writing system. So basically, like English, we write left to right. Oh, cool. I didn't know that. Yeah, MDN surprised me because they have quite a few tutorials. They had one I used the other day for hitbox detection. I just copied and pasted it. So yeah, they have a lot of cool stuff on their site. So start and right. So English we write left to right. So start is the left side and end is the right side. If you were using a language that writes right to left, then start would be the right side and the left would be the end, or end would be the left side. I've never written any Canvas stuff that is multilingual like that, so I've never used start and end. But if you wanted to try to build something like that, that's what you would need to use. Okay, that's text line, and then text baseline has more options. So we have top, hanging, middle, alphabetic, ideographic, and bottom. And they have a nice graphic to show that. So top is the top of it. Hanging, you can't hardly tell in that font. But hanging is basically, it scooches right up to the stuff on top. So if you look here, I'll zoom in a bit. There's a teensy tiny gap right here. For top, because it's kind of the calculated top of the font, and then hanging is like gonna smush right down on top of the top stuff. The middle's in the middle. Alphabetic is basically like how you would write if you're writing on notebook paper. So So our descenders, like on our G and our L and P, go below the line. So that's how you're used to writing in school. Kind of annoying. This is actually the default if you don't set one, but it's kind of annoying to work with a lot of times as a programmer. But if you were like you wanted to simulate, let someone type and like show it, on a line, this is what you could use. And then ideographic is basically hanging, except for the bottom, so it smushes right up against the descenders. And then bottom is like top. It's kind of the defined bottom, which leaves a teensy tiny gap in between them. Usually I'll end up using top, middle, and bottom, but on occasion you'll need to use the other ones. So, okay, so that's our text. So, now we talked about text and we talked about rectangles. Now, for everything else, you're basically going to be dealing with paths. So paths are basically, and Photoshop pretty much has one where we have the pen tool. But theirs is fancy because they use, curves. What do you call these? A Bezier curves. That's the word. We don't actually have that. Well, we do, but we're not going to talk about that today because I hate them. But when we talk about paths, we're talking about, so we'll generally we set a point where we start off, and then we're going to be like, okay, make a line to some other point, make a line to some other point, make a line to some other point, make a line to some other point. And usually you'll do a closed path, so you'll get back to where you started. And then when we stroke, it's going to fill in everything for this we made, or it's gonna color the line. Just drawing a path won't make a line there. You would have to stroke the line to actually get a line stroke on there. Or we're gonna do an arc, which is basically like drawing a circle or part of a circle around some point, like that. And we're gonna erase that because. So yeah, so let's go do a simple one first. So we'll just do we'll do a square or a rectangle, but we'll draw it as a path. So we do CTX and we start with begin path, and what begin path is basically saying is that here until basically I do something else. This is when I call stroke or fill. This is what I want you to stroke or fill. And then we'll use move to. So move to is kind of like you're picking the pencil up and moving it over to a point, but you're not like putting the path down. So we'll start at 100, 100. Then we're going to do line 2. So this is like we've put the pencil down and we're going to now draw from 100, 100 to whatever we put here. So let's go, we'll go 300, 100. So that's going to be... so I started at 100, 100. So I'm going 300, 100, which would just be over here. So I'm just going this way. And then we'll do another line 2. And we'll keep the same X, 300, and change just the Y. So that's going to be from here down. And these are 200 wide because that's the difference in the two numbers. So that's 200. Then if I want to do a square, I'm going to go back the other way. So I'm going to do ctx.line2. So I'm going to go back to 100 and I'm going to keep my y the same. And then for the last one, I'm going to go basically back up to the starting point, 100, 100. And then we'll call close path. And close path is kind of optional, but I still recommend calling it every time. And then I'm just going to run this real quick to show you that we haven't actually drawn anything yet because I haven't called fill or stroke. So now if I call fill, and this time it's just fill instead of like fill rec or fill text, it fills it in for us. Or if I call stroke, it'll stroke it for us. just like our square was, or rectangle was, except now I'm drawing the path specifically. And like obviously I don't have to make everything even, so like if I change this one and I go out like 500 with this one, see it, that point's now out here, so we went boom, 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 boom. And if we wanted to draw something more complicated, like say, let's do like a triangle. Sometimes you might have to do, I know, triangle's more complicated than square. Kind of is. Not for just any old triangle, like I can just kind of make up points. So we could do move to 100, 100, line to, say, I don't know, 150, 200, ctx.line to, go back the other way, 50, 200, ctx line 2, back to where we started. So that'll give me a triangle, but it's not exactly a perfect triangle. If I wanted like a perfectly equilateral triangle, I would have to do a little bit of math to work out what shape it is. So like what if, let's see how, if I remember basic geometry. So if we want 100 on all sides, then from here, this guy would have to be 50 over, so my x would be 50, and then we need our y, what is it? Is it half base height? Oh, I want to solve for height, which I don't know. All right, yeah, I don't remember my basic geometry. But anyways, but yeah, so you might have to do some math for that. But usually if you're going to do any complicated paths and you don't have a reason to do it dynamic, you can also, we can also just create images and bring them in. So, stop trying to draw with the pen. So I'll just like make this smiley face here. And we'll export that as a PNG. Actually make it transparent. Doop, 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 redraw. Export, quick export as PNG, projects, beginner coder, now let's put it here. So we can bring in images. To do that, we have to load the image, and to load the image, we can just do, we can create an image element. So just like we created the canvas up top, we'll do image. Then we set the image source to be the path to the image. So let's just be smiley.png. And the dot slash here basically just means it's in the same folder as the current page. And then, so this will load it up, and then I can draw it with ctx.drawImage. And then I pass in the image, and then I give it the X and Y. So I have a couple options here. So destination X and Y, just where on the screen it can do, and it'll just draw the whole image. Or I can take a part of the image by providing the source X and source Y. So that would be the X and Y in the image. And then width and height. So like if I only wanted to draw a chunk of the image. So we use this for like when we're using a sprite map sheet. I could take part of the image and draw it to a space. Or, and this one's like the first option, I can just, it'll use the whole image and I can specify where to put it. But I specify a width and height for how to put it out. So it'll like shrink it down. So I'll just use the first one for now. But there's a gotcha with this in that, it's not a, yes it is, leave me alone. Oh, actually, I guess maybe for new image you can also just do new image like that as well, which makes this thing more happy because it knows it's an image. The gotcha notice nothing showed up. The reason for that is because loading an image is actually what's called an asynchronous operation. Asynchronous means, so most of the, well, not most, literally everything we've done so far has all been synchronous. So that means like this will happen, and then it'll wait until that's done, and then this will happen, and then I'll wait, and then this will happen, and then ignoring that, it'll keep going, and each step is done before the next one runs. Asynchronous code, it'll kick off, but it doesn't wait for it to finish by default. So it'll actually keep going. Or it'll keep going, but that means that, so that means that when this is called, our image isn't loaded yet, so it's going to draw nothing, basically. It's going to draw the no image it has loaded. So what we have to do for images usually is we have to add what's called an event listener to the element, and we can add these to pretty much any HTML element. And the first parameter is the event. So in this case, I'm going to do load, or the event name or type. So load is the event I'm interested in, and that'll go off when the image loads. And then the next one's a listener function. So here I'm just going to, for a second, I'm going to console load, or console log, and just say it loaded so we can see it fire off. And so basically when image is finished loading, it's going to send out an event called load, and this guy's listening for that, and so when it gets it, it's going to run this function. So we can see it loaded, and it loaded really fast. You probably couldn't tell which one of those happened first between the draw and this, but problem is this one happened second. So, but what we can do then though is we'll draw our image inside of here, and then it'll show up. So what you normally do in a game, because you don't want your kind of images to be popping in all, willy-nilly, is we would generally have some step to load all of our images up first and wait for them to all get loaded before we start doing things with them. And that's the same as when you're playing a game on your desktop computer and there's the load screen. That's pretty much exactly what they're doing. They're loading up all the models and images and everything ahead of time so that when they go to draw your world, they're already loaded up. So we can do it like this. Or what we could do too is we could also put all of our code inside of the load image, and really that's kind of what you do when you're dealing with it for real. And we could get fancier with promises and await and async and stuff, which we're not going to worry about today. But we'll probably talk about next week or the week after that, dive more into async stuff, because that's really important for JavaScript, because a lot of important stuff you want to do is asynchronous. But I just wanted to kind of show you that you can draw an image. So usually you're not going to try to figure out how to draw, draw the Mona Lisa with a path. You're going to just bring in an image of the Mona Lisa and put it on there. But yeah, so we'll just copy that out for now. Okay, so we have our paths here, and then if we want to draw circles, it's pretty similar. We still use move to, but instead of line to, so line is obviously a line, we're going to use arc. So arc, we give it, the X and Y is actually, so an arc, also a curve. If we do an arc all the way around, it's a circle. My lovely rendered, not totally completely squished circle. So when we draw that, we draw it based on some point. So if you've ever used those compass tools in Trig, let me pull up a picture. Compass. Not the thing to get around. These guys, where you set down the one point and then you have a pencil on the other and you draw it around. That's basically how we can think of the arc function. So our X and Y is actually the point that doesn't draw anything in the middle of the circle, and then the line we get is going to be around that some radius away, some R away. So if we want to, so let's draw an arc real quick. So I'm just picking some arbitrary place right now. And then the radius, so like I said, how far away from the center it is. So I'm just going to put 100 again. And then our start angle and end angle, we specify both of these in radians. So if you don't remember radians from school, so normally we think of, I think almost everyone except maybe mathematicians and scientists think of, degrees by, 0 degrees, and then you go up here and it's 90 degrees, and you go up here and it's 180 degrees. Down here is 270 degrees, and then back here is 360, so full circle. Radians are just another way to express that. They work the same, they're just different. So 0 is still 0, and then 90 and a full circle is 2 pi. So a half circle is just 1 pi, 90 degrees is half pi, and then 270 degrees is 3 halves pi. And then in between there are, whatever. So we'll be using radians. And there is an easy formula to convert it. I say easy, and now we'll see if I can actually remember. So if I wanted to convert like 180 degrees, it's that divide by 360. Well, actually divide by 180 times pi. Yeah, so that'd be 1, or 90 divided by 180 times pi is half pi. So that's degrees to radians, and then the other way around is, what is it? Just radians divided by 2 pi times 360 maybe? Or divide by pi times 180. Yeah. But yeah. So, but yeah, most of the time when you do computer stuff, it's going to be computer-related trig stuff. It's going to be in radians. Though surprisingly, Unity actually uses angles, like 0 to 360. That kind of surprised me a bit. I don't know what UDK uses or any of the others. Okay, so we'll do a half circle for now. So we'll do 0 and we'll do pi. And so to get pi in JavaScript, we do math.pi, all caps, because it's just a constant it defines for us. And then we'll fill and stroke that. Let's leave that. So we got that. And then what might have caught you off guard is it actually is probably upside down from what you were thinking, because normally when we think of degrees, we go this way. But by default, it actually goes clockwise. So there's another parameter we can add here, anti-clockwise, so we can do true. And that'll actually drop the other way around. So that's a half circle, and then if we did 2 times pi, we'd get a full circle here. Yeah. And we actually don't want that there. That's why we have that weirdness. So there's our circle. So that's how we do arcs. So we could do like 3 halves pi. We can get, all right. Put that another way. So we can get chunks, or yeah. So yeah, and you can see it's just kind of, when I stroke it and fill it, it's just kind of filling in the gap, because technically I left a gap here in my path, but it's pulling it out there, and we can see that's what close path did for us. It closed it up. So without it, we still fill in the same space, we just don't have a nice clean line going back to the start. And so one thing that's so let's draw, because this is kind of a good exercise of both, is a rounded corner rectangle. So this one's kind of interesting when we're doing it with the canvas. Can we, not that. So for this guy, we're going to have to mix lines and arcs. So we'll start out. So first I'll just draw the rectangle we're going to follow, and that's squiggly. Alright, so we're going to go, we'll do it from 100, we'll make it 300 wide, 200 tall, and this will be 100 by 100. So we're going to start out, and we'll give it a 10 or a 20 pixel radius. So when I say that, what I mean is, so if we have a square corner, then a 20 pixel radius would take it in 20 here and 20 this way. So we'd basically not do these 20 pixels here. Let me get a white background on there. So we wouldn't do those, and then we're going to fill in with a stroke here. So it'll be a 90-degree semicircle in the corner here, and its radius is going to be 20. So we're not going to draw the line for that 20. So basically we'll start here, we'll go out to 20 away from this edge, then we're going to draw an arc from here with that as our corner, 20 pixels away, then go down here 20 pixels away, draw corner, go here 20 pixels, blah, up here, blah. And if we get it right, we'll have a nice rounded rectangle. So let's go, and we'll do this. We'll make some variables to track some things so we can play with them. So we'll do radius, we'll do a width, what did I say, 300 by 200? Yeah. We'll do a height, we'll do an X, and we'll do a Y. And not only will this let us play with it, it'll also make it so it's a lot clearer what all the number mishmash is doing and what all the math is behind what we're doing. So let's start out. We're going to move to, so we'll start here and we'll go clockwise. So we're going to move to our XY plus our radius only along the X because our Y is still at the top. So our X is X plus radius, then our Y is Y. Then we're going to do line 2. So we're going to go 20 away from this edge. So, but remember that we're also already 20 off here. So we're actually going to subtract 2. Well, actually, we don't need to worry. Maybe we do. Let's see. So we're going to do X plus radius Y. So we're going to start, X plus width. So X plus width would be if we started here and we go all the way across. But then I need to stop at 20 short. So minus radius. And then Y is still the same at this point. Okay, and let's go ahead and we'll look at it as we go along. So we got our first line. Doesn't look like a whole lot just yet. So now we're going to arc. So we're going to arc, and we need to put our compass point down 20 from the top and 20 from the right. So 20 from the right is where we just drew a line, so we can use that same X that we have above, which is with minus radius. And then 20 from the top is just, or radius from the top, so Y plus radius. And then our start angle is going to be 0. Oh, wait, let me think about this. No, our start angle is going to be math.pi divided by 2, which is 90 degrees. So 90 degrees would be up. And I may totally do these angles backwards. I do about half the time. And then we'll go to 0. Oh, wait, did I miss one? I did. You need to specify the radius there. And then 0. And then we'll do anti-clockwise false, which is the default, so we don't need to specify it because we want to go clockwise. And I did do it backwards. Yep. I usually do. 0. No, that's still backwards. That's actually more backwards. Hang on a sec. Start is... Oh. Because our angles are actually upside down. 3 halves. Go to 2. There we go. Yeah, so when we're drawing clockwise, we take, we normally think of it this way. We are rotating it this way so that we're going this way. So it was actually this point we were doing to this point. So, okay, so that's that one. All right, and then the next line. So we're now right here. We're going to go down here. So we're going to go all the way to the right. So that's x plus width. We're not going to subtract the radius because we're all the way over now. Then we're going to go almost all the way down, except we're going to stop radius short. So y plus height minus radius. Then we need to do another arc. So this arc, we're going to put our pencil down 20 away from the right edge, 20 away from the bottom edge. So x plus width minus radius, y plus height minus radius, then radius, and then our angles. Let's see if I can do it right the first time. So we're going here to here, so that would normally be 0 to 3/2 pi, or 270 degrees, but this will actually be our 90. So we're going 0 to 90, or 0 to half math.pi. Alright, let's try that. There we go. So we got our line, another curve. Now we can go. So now we're going to go here. So it's 20. It's radius away from the edge plus x, and then all the way down for y. So x plus radius, and then y plus height. Okay, and then another arc. So this time our compass point is going down just radius from the right plus x, and then all the way down except minus 20 for that. So x plus radius for the left, and then y plus height minus radius, and then radius for our thing, and then our angle. So let's see, normally this would be 270 to 180, but we're flipped around, so it's 90 to 180, or math.pi divided by 2 to math.pi. Okay, so there's that. And then we'll do the last line, and that one's going to be right here. So that is radius from the top and all the way on the left. So just x for the left, and then radius plus top. So there's that one. And then finally, our last arc. So our pencil, or our compass point goes down radius radius. So x plus radius, y plus radius. And then our radius. And then our angles. So normally it would be 180 to 90, but flip those around. So it's 180 to 270, or math.pi to 3/2 math.pi. There we go, rounded rectangle. And thanks to us doing these all with a bunch of variables, now we can play around with it. So like if we wanted, say, 50 radius, we can do 50 radius and it'll pull it in. Or if we wanted it, wider, we can stretch it out, or we can shrink it down. The only thing that's going to be funny is if we shrink the height less than 2 times the radius. We're going to get something interesting here. Let's go down lower so you can see more extreme version. Because our corners are basically drawn kind of inverted. Normally in like CSS, if you do a rounded rectangle, what it would do is it would actually trim down the radius to be a maximum of half your height, so you would never get that inversion. So it would do like that, even though your radius was technically bigger. But yeah, so cool. And then and if you want to draw multiple paths on one, all you do is you just repeat this over again. So like I'll just draw a fill rect. Do that, and I'm going to change the fill style, so we'll get a different color. And then we'll say, let's begin a new path, and we'll just draw like a circle at 300, 300, and we'll say it's 100. Give it a different stroke style. And we'll just do a whole circle. Stop. CTX.stroke. So you just keep drawing them and you just keep getting more. And basically just like I said, begin path is where it knows like one starts and the other ends. You don't strictly have to have close path and it'll still work. But if I like left this begin path off, weird things would happen. Like that, because it connected the two. So it treated that last stroke, it treated all of this as one big path. So just remember to have your begin path there. And usually it doesn't hurt to have your close path. Sometimes you may purposely want an open path, so you would purposely leave it off. But unless you purposely want an open path, I would generally just put it on. Okay, so that's how we draw. So now how would we start approaching making a game with this? So basically, all a game is every frame. So frame is, what we call like one single moment in a game, one singly drawn picture. So both, a game and just regular animation, it's a series of still pictures just shown to you real quick, like a flip book. So in a game, all we do is we draw out one frame, wipe it away, draw out the next one with things moved a bit, wipe it away, and we just keep repeating that forever. And so that's where the frames per second comes in, your FPS. So 60 frames per second means it's doing that, draw something, wipe it away, draw, wipe. And actually, depending what you're doing, you may not actually do the wipe step. Like if you're doing like a 3D game and you're drawing the entire screen every time, you don't actually need to wipe it every time. You can just stack it on top of one another, and that's a little faster. But basically, it's drawing 30 of those pictures out, or 60 of those pictures, or 144 of those pictures, whatever your FPS is. That's how many of those pictures it's drawing per second. So let's just go, and so here, I'll chuck this into into another file just so it's there. Call it drawing. So I can wipe this guy out. And actually we'll keep this part, or keep that part. Okay, so let's say we'll use our smiley face since we already have him there. So I'm going to create that. So this equals ./smiley. And then we'll do image. And how we'll do it. How do we want to do this? Let's do the simple way for now. Have that listener load. So we're going to make a function called start that'll have our game code in it, and we'll have load call start or have it call start when the image is loaded. That way, by the time we get in here, we know we're loaded up. So this is kind of our setup code here. Okay, and we'll just real quick make sure that that's getting called. Can I? Oh, duh. Yeah, we need to stick this down here. Start. We have the reference to start has to come after we actually have our start function. Okay, there we go. Start. Okay, so we'll put all our start code in here. So let's start off. We'll just draw our smiley. So draw image, and I'm just going to draw him at 100, 100 for now, just to get him on there. Okay, so there's Mr. Smiley. So now, let's say we want to like move Mr. Smiley around the screen. So let's start with, instead of just putting numbers here, let's put those in variables. And we'll use let, because we're going to change these variables. So we'll start them off at x and y. X and y. Okay, so he's drawing now. So now what we're going to do is what we really need to do is every time we change something, we're going to need to redraw. So let's actually make another function called draw. And we're going to instead do the drawing of Mr. Smiley down here. And now, we didn't talk about this last time, but these variables in JavaScript have what are called scope. So because I created these variables inside this function, they don't exist outside of that function, which means they don't exist down here. So if I call draw down here, it doesn't know what x is. So I need to pull these up into a higher scope that they both can access. So I'm just going to pull them up all the way to the very top of our file for now. And now both of them know what that is. So there's our Mr. Smiley. And so now we'll draw him, but we're still only drawing him once. So usually what you'll do in a game is, what you'll do in a game is you'll usually have a game loop function. I generally like to call that my tick function. Like tick as in like, you know, the sound a clock makes. You know, you can call it whatever, name doesn't matter. So instead of calling draw, I'm going to call tick, and then I'm going to have draw, or tick call draw. And so I can do something up here, like say I add 50 to Mr. Smiley's X, and then I'm going to draw. So he's moved over now. And then what I want to do for my tick, and actually let's shrink that to 10 for a second. And then what I'm going to have it do, so tick's job is basically to update one frame. And then what I'm going to do is I'm going to use the set timeout function, which is in JavaScript. And what this does is after some amount of time, it'll call the function I specify. So I'm going to set a timeout. I'm going to have it call tick again after 100 milliseconds. So timeout's in milliseconds. And so if we wanted to know our FPS, and this is actually a slow one, we would do 1,000, because there's 1,000 milliseconds in a second, divide by that, so 10 frames per second. That's really slow. We could also, and this have a FPS variable. So if we want to draw 60 frames per second, we'll do 1,000 divided by FPS. And that'll give us 60 frames per second, which means each frame would be 16 milliseconds apart. So we'll do this. And let's actually turn the FPS back down. Well, here, I'll show you why. Oh, actually, that wasn't that fast because it was only 10. So now basically every tick, we're just making Mr. Smiley move 10. But notice we get this kind of after image trail because we weren't clearing out in between. So since we aren't filling the whole screen right now, we wouldn't want to clear the rest. So 0, 0, canvas.width, canvas.height, so we clear the whole thing. And there is such a thing as like partially clearing the screen, and some more advanced systems may do that. Because if you like only need to redraw, you know, like a little part of your screen, it's faster to just, you know, redraw that little bit than it is to redraw your whole entire screen. But we're not going to worry about that for now. So now Mr. Smiley's moving off of our screen. So now we have a basic animation here. And now if we want it, so then to, you know, make this into something starting to resemble a game, and instead of just making him arbitrarily move, let's move him based on our person doing something. So in order to get keyboard input, we're going to use an add event listener again, and we're going to add an event listener on can we do it? No, we'll do it on the canvas, but only certain events get, actually we'll do it on the root element. Doesn't really matter which one we do it on. Well, not super duper. So we're going to do key down, one for key down, and one for key up. And by default, not every element can take events. So I'm going to do console.log key down just so we can see when they fire. Console.log key up. So those aren't going off even though I'm hitting keys, because by default a div, which is what the root element is, can't take key input. if you give it a tab index, it can, though. Well, maybe. -1 might not work. Oh, no, I have a typo. Capital I here. Now you can see my key down, key up firing off every time. So now I can receive the keys, and with the event listeners, they have a parameter that can come in called event. And on event, it'll tell me, and I'm just going to console log out the whole event so we can look at it. It tells me which key was hit. So there's a number of ways you can handle this. If you want to check out the small JavaScript game engine I wrote that I use in most of my streams, that one actually will just create an array of all of them, and then we'll just check them. For our simple one, though, let's just add some variables for x direction and y direction, and we'll just look at what's here. So we'll say if event.key equals right arrow, or arrow right, then we're going to set the x direction, and remember our graphics go positive, negative, so his direction is going to be 1, positive number. Else, if event.key equal arrow left, then his x direction is going to be -1. And if it's neither of those, we're going to set his x direction to 0, because that means we're not moving him. So now we have this x direction. So now in our tick, we can use the x direction to update the x. And so this just by 1, so we want some kind of speed variable. So we'll say 100. And usually you want to do your speed like 100 pixels per second. So this code right here will do it 100 pixels per frame, which means he's going to do that. He's pretty much going to run away. And he's back, and he's back, and he's back, and he's back. He's moving a little quickly because we're doing 100 frames per second. So basically we're doing 100 pixels per frame. 60 frames per second means he's basically moving 6,000 pixels a second. That is 3 times the width of my monitor per second. That's a little fast. So what we usually do in games is we'll keep track of when we last did something. And we'll initialize that here. And we'll use date.now to get the current time. And then here in our tick, we're going to get now again, date.now, and then we'll do a since last. And the since last would be last tick, now minus last tick. So that's how many milliseconds it was since we last did our tick, which should be about 16 plus or minus 1 or 2. And we have to make sure we update last tick equal to now again, or else it'll just keep adding. There we go. So you can see, so we're fluctuating between about 16 and 18 frames per second, because you won't ever get perfectly distributed frames, but you generally, unless you're lagging, you'll get pretty close. So we're probably running at more like 59.9 frames per second right now, but that's cool. And most games are doing that too. It would actually be very weird if your game was running at perfectly 60 frames a second. It's probably running at like between 59.5 and 16.5 and rounding down to 60 when it's showing you your FPS. Okay, so now that we have our since last, we can now use this as a multiplier to speed. So since we wanted speed to be 100 pixels a second, we're basically doing we need to actually do that divided by 1,000. So this will give us our fraction of a second that we've just done times speed. So that way, after we've done 60 of these, this will be 1 second worth, so we would move 100 pixels per second. And we multiply that by the direction to control which way he's going. So now There we go. Much more controlled. Then I can go left and right, and when I let go, he doesn't stop because he hates me. Why didn't you stop? Oh, wait. Which one did we put it on? Oh. He didn't stop because I put this on key down, but this isn't a key down. This is key up. So on key up, we want to do x direction equals 0 for now. Or actually, we'll want to do if event.key equal arrow right or event.key equal arrow left. Then we'll want to do that. So if we just let go of either of the x ones, we want to stop. So going right, going left, let go, he stopped. Right, left, right, left, right, left. And it is a little bit shaky simply because doing this check here, if I've like started hitting the left key before I let go of the right, it'll jitter like that for a second because I told it to, check either of these. So, and again, this is kind of a what's the word I'm looking for? It's a naive. There we go. This is kind of a naive approach to do this. Normally what you would want to do instead is, and why don't we do it? It's not actually that much more complicated. We'll say keys down, and we'll just have an array of keys down. And then we'll do keys down dot push event.key. And actually we'd want to check to make sure it's not already in there first. So if not keys down dot includes event.key, then we'll push that key on. And then similarly, we'll take it out. And to take it out, we'll get the index of it. Keys down dot index of event.key. And then if it's in there, the index is going to be 0 or greater. If it's not in there, it's going to be -1. So we just need to check if it's -1. And if it's -1, we're going to call splice. And splice takes the start index, how many we want to delete, so 1. Or sorry, the start of where we want to start the delete, which would be index, and then how many we want to delete. And that'll take it out. And then down here in tick, we would check if keys down dot includes arrow right, then x direction equals 1. Else if keys down dot includes arrow left, x direction equals -1. And then we can just do that here. So it'll either be 0, 1, or -1. And this way will work a little better because now even if I start holding both, it won't jitter because we're not actually stopping it. We're just changing which key we're going to end up checking. And because I did right first in this list, if I hold both of them, right wins. Or left wins. I could also, if I wanted it to actually stop when I'm holding both, I could actually do +1 or -1 from 0, so that way it ends up being the same for just one key. So 0 + 1 is 1, or 0 - 1 is 1. But then if I have all three and I don't do an if else, then I'll end up back at 0, so it'll actually stop again. Which, depending on the type of game, might be preferable, might be annoying. So it's kind of up to you and what your game is. So there I'm holding both, or holding none, holding just right, not holding any, holding left, holding none, holding both, blah, blah, blah. And then to do Y, it's pretty much exactly the same. So I'm just going to copy all this, and I'm going to put the variable declarations together, and then arrow up, arrow down, Y, Y, and then this is just the same, Y, and there we go. So now, oops, except I did his, these backwards. So up is actually negative and down is positive in computers. So there we go. So now I can go all over the screen. So this is kind of a really simple implementation, but now you can see that, basically just getting your input is just a matter of looking at what keys you have and then updating some variable. And this is a pretty simple implementation. If you check out the game engine that I wrote, we actually use, instead of tracking the X and Y, or we still track the X and Y, but instead of doing separate values for width and height, or for X and Y's direction, we actually do, we keep track of just one point, which is X and Y. So right now, we're keeping track of X, Y, and we're keeping track of XD, X direction, and YD. But the gotcha with that is, so we have our speed 100, but if I'm going both of these, I'm actually going a little bit more than 100 pixels total. What we do in the engine we use for the game normally is we still keep track of X, Y, but instead we keep track of direction, so the angle we're moving, and then velocity, the overall speed we're moving. And that's usually what you'll want to do in most games, and that's kind of like taking the physics approach. But this is a nice simple way, and this actually works for a lot of different types of simpler games, or especially if like you're only moving in one direction. Like, do I still have it open? No, I closed it. Let me open it real quick. And all the games built on this guy are using that demo engine. And it's not really an engine meant for like creating like a game you want to release to someone. It's more a teaching tool, so it's kind of pretty simple. But this guy actually is using that approach, even though we're moving in one direction. When I first built this, we were doing it the way we just did it, because I only needed to keep track of Y. But then I changed it to use the physics. And it also has a little bit of, it has like acceleration and friction, so you can see it's like speeds up and slows down and stuff. And then this guy's the same. So I'm keeping track of direction when I move, and then, but yeah. And then, like if we want to shoot bullets, it's basically just, we create different objects, and usually you'll want to create classes for each of these or something like that, because if you try to have it just in one giant function, your code gets ugly. So like in this game, we have a player class, we have a zombie class, we have a bullet class, background, etc. Thank you. Is your engine using pointer lock API? It is not using the pointer lock API. I kept it kind of as simple as possible to make it so if people wanted to look at it, they can kind of understand it real easy. So, but yeah. If you just, with the basic things of just figuring out where to draw a thing and drawing it, you add one little piece, and you add another little piece, and you add another little piece, and before you know it, you end up with a game. And that's what that's the kind of stuff we do in the normal stream. So, if you're interested in that, check it out, because that's what we build up. And it's actually the same for 3D, too. So I started playing around with a Unity project on yesterday's stream. Well, Monday's special stream, and then we also did Wednesday. But 3D is the same as 2D, basically. You're just, instead of thinking in X, Y, you're thinking in X, Y, and Z. And some of the math gets a little harder, like 3D trig is a little annoying. But like I was talking about earlier, though, when you do a 3D, a lot of libraries and stuff will have things to simplify a lot of that logic for you, so you don't have to, have a PhD in math to be able to figure out how to do 3D stuff. But yeah, that's it. And then, so for enemies, we would just have a second thing we're keeping track of the position for. We draw it, we hit the enemy. Actually, that's one thing we can talk about real quick, and how we deal with collision in games. So we won't worry about coding all these right now, because it's getting kind of late, but we will just talk about real quick the types of collision. So, when we think of a game, anything in a game, so let's think of our player, for example. So, our player has an X, Y, width, and height, really. And that X, Y, plus the width and height basically form a rectangle. So, one of the simplest ways we do collision is based on, usually you'll call these hitboxes. And so it's just hitbox collision. And so like for a simple one, we may have just one big hitbox around the whole thing. And in fact, that's what we do in those sample games I just showed you. So we would just literally check, is this hitbox and this hitbox overlapping one another? So if there's any kind of overlap, that means they hit. And actually, I'll pull up the code real quick to show you that. It's in rectangle. So hit rect. So basically, all we're doing is and this one's a little more complicated because the game engine has a concept of origin. So the origin may be here. So that means the X and Y is actually setting this, and then origin's kind of an offset to get back to its like natural X and Y. So that's what the extra origin bit is. But basically, it's just we check the X of 1. So let's draw it in 2 colors. We draw. So these lines are one axis, so the x-axis of 2 different rectangles. And so this would be its x over here, and then this is its width. So we'll call this xr and width r, or actually rx and width x. Or that, what I wanted, rw. So red x and red y, red width. And then back to the blue color, BX and BW. So basically what we're checking is, so ignore the origin stuff, basically. So is the X of the first one less than the X plus the width of the second one? So is this one less than this value right here? Actually, let's do green for making points. So it's that value less than that value. And is the x plus width of the first one greater than just the x of the second one? So is this point greater than this point? And if that's the case, that means they're overlapping. So in this case, they are overlapping. So because this one is less than this side and this one is greater than that side, if they weren't overlapping like this, we could see, okay, well, yeah, we're still less than here, but we're not greater than here. So they're not overlapping. And then basically you just, for a rectangle, you just then do it for the y as well. And so if both directions are overlapping for a rectangle, you end up hitting, so you're hit. Another way you do hitboxes, and like a lot of so that hitbox works for really simple things. It's not the best because, like, especially if you had something like that spaceship game is probably an example of this. If something, so it's shaped kind of like this, well, the hitbox is like this. So that means if an enemy clips me right here, it won't look like it hit me at all, but that counts as a hit in that game because we're using a really simple hitbox. But this approach works well, and like if you want to do like a like a sprite-based, say like RPG tile-based game, like something you might make in RPG Maker, for example. This can work really well for that because you don't need lots of precision, and it's really fast. That's one of the nice things about Hitbox is the formula is super fast to calculate. Because pretty much everything in game design is some balance between quality and performance. So you always have to kind of pick where do you want to line up on that line. So with basic hitbox, we're way over here. Low quality, good performance. What nicer 2D games will do is they may have, especially like 2D fighter games, for example. Oh, what happened? Something happened. Oh, thank you, Menahan. Is they'll have something like a Street Fighter, for example. So Street Fighter, let's draw my awesome Street Fighter character here. You know, they have body with moving parts. Look, you could just drop that into the game right now, couldn't you? So that doesn't look good. Arm. So, you know, they have a whole bunch of moving parts that make up their body. So one way you might approach that is you can actually do a hitbox around each part, or even multiple hitboxes on one part, to make them nice and tight around whatever you're hitting is. And they do still have to always be rectangles, and a lot of times you'll want them to actually be oh shoot, what is this? Axis aligned bounding box. That's it. AABB. An axis aligned bounding box, and all that is a fancy term for the box. So, like, you know, if you have an X and Y, your box is always perfectly even with it, versus like being like rotated. So, an axis line bounding box always has to be lined up with the axis. The axis line bounding box is the cheap one that puts us really right here for high performance. If you start rotating it, you're making your math more complicated, and you're ending up somewhere over in here. So usually there'll be axis aligned bounding boxes. So really, it shouldn't be turned like that. It should be nice squared off ones like this. Which works well in some cases. Sometimes it doesn't, because, like, you know, if I had, you know, some arm going this way, my bounding box still looks like that. So you could break that down into smaller ones like this, and kind of get in between, but then you might be talking about tons and tons of bounding boxes. But a lot of 2D games that care about better stuff will do that. And then basically it's the same math you did for the simple version. You just do it over all of these, and if any of them hit, then you connect. Or like you can also use that approach if, like, say you have, you know, like an enemy with a weak spot of like the head. Well, you can have the head be one hitbox and the rest of the body be another. And if they hit this one, then they took extra damage, and if they hit this one, they didn't. So lots of uses for that, and that's a pretty common one that's used in real games even. Because, again, it's cheap. If you do that, you're still pretty over here in the performance scale. Even if you had like 100 hitboxes, that's still quite cheap, computer-wise. And so, like, one way I could improve, like, the spaceship would maybe be to start treating it like 3 hitboxes like this. And it's okay even if the hitboxes overlap. It won't, in your one thing, it won't change anything. So that's another way. Then another way would be to have rotatable hitboxes. So benefit of that is you can make it more tightly around whatever you're hitting. Downside is the math for these is quite a bit more complicated. So on our line of performance versus quality, you're probably somewhere in the middle, realistically. I'd say you're somewhere kind of in that kind of timeline. And then pretty much the other one is, for 2D, it would be pixel perfect collision. Or in 3D, it would be actually checking the meshes. But the idea is the same for both of those. So, like, if I had that and I had, like, a sword, it would be checking the actual pixel values to see which pixels overlap. And that one is going to get you your best quality for hits, because that means you can, like, dodge, you know, with just like a millimeter. But that's going to firmly put you over here, because now what you're basically doing is checking every single pixel rectangle. So you're treating like every pixel as a hitbox. And there's a lot of pixels in stuff. So that gets really expensive. Same with meshes. So in 3D, if you had like 2 3D cubes, seeing if they actually overlap. And there are ways to make this easier. Like one nice technique you can do for pixel perfect in 2D is you can actually, when you draw things, you can actually draw them
in such a way that if two things are drawn on top of one another, they actually cause the overlapping part to change colors. So you can just go and check to see if any of those pixels are that color that you're looking for. But that's still pretty expensive because that still means you need to look at every single pixel in the image. And if you have, something tiny like 100 by 100 image, that's already 10,000 pixels. And realistically, you're going to have something much bigger. So, but yeah. And the math for but yeah, and we'll probably end up implementing the pixel perfect version in our game engine soon-ish, just because I kind of want to implement it. Yeah. So yeah, those are your different ways to do collision. But normally you'll stick with some version of hitboxes, just because they're nice and easy. Axis aligned hitboxes, or axis aligned bounding box technically. What do they have in here? They have a... Yeah, and the same applies for 3D too. It's just like we had our math here for 2 dimensions. You'd literally just add a third check here for Z, and suddenly you have 3D hitting axis line bounding box. And that's probably what they're describing here. Yeah, so see, you can see there's a nice little formula for it. And the min and max are basically, min is just x, and then max would be x plus width, essentially. And then, and they have another one for point sphere. And this one's fairly cheap too, because you can do math to pretty easily check if they're overlapping. Sphere versus that, and bounding volume collection. Yeah, and then this is probably where it gets more complicated, and this would actually be checking if they're... I don't know. This is still basically bounding box type stuff. But yeah, and usually you'll want to do the bounding boxes because it just gets too expensive to do the other. And when I say expensive, I mean in terms of resources and game performance. More expensive code runs slower. So, and you usually want your game to run fast. But usually, with this, you can get pretty good for most games. And really, it's only going to be like, fighting games that it's really going to matter what, if you have that little bit where my hitbox is here and they graze my shoulder and the bullet hits right here and I'm dead. And sometimes you've probably played games where the hitboxes sometimes aren't quite right, and you're like, I dodged that hit, but you're still totally sent flying. That's because they're using a bounding box that maybe is a little bit bigger than it should have been. But yeah. So, cool. I think that's about it for today. Talked about drawing, we talked about, basic movement and hitting, and I mean, really, a game is just, you keep layering up those basic techniques there, and eventually you'll have something that's the game. You just build it one little bit at a time. So before I go, I'll get this code. Actually, we'll go ahead and get this code pushed up. So last time we talked about how to use GitLab, which is our repository for where we store our code. GitHub. GitLab is if you're doing professional stuff and need a place to host your private code, GitLab is really a really nice one for that. So I'm going to we'll do it this way. I'm going to add all my changes with git add, so now they're all green, so that means they're staged. Then I'm going to commit, and added canvas drawing. And then I check. All right, so I'm good. I just need to push up. So I'll push it up. And if you need links to GitHub, they're on my channel. If you want to pull down that code or the engine code we use in the normal stream, feel free. If you want to, get in touch, you can ping me on Twitter or on Twitch or on There's a Discord channel set up. And this video and the video from last week and every other video is on YouTube, and links for all that's on the channel. So, yeah. Thanks everyone for joining. I hope you learned something, had a good time. Bye everyone.